Assalamu alaikum dear students. Today we are going to discuss the first chapter of the paper second, that is integration. You know how to find the derivative of the function. What are the applications of derivatives of the function, or where we use the derivatives of function. Now in this differentiation or in this integration, we are studying the changes of a variable, of a variables of a function. So actually this differentiation as well as this integration is the part of calculus. Calculus is the branch of mathematics which simply deals with the study of the changes in the variables which are related by the function. Now this calculus has two branches, mainly two branches. One is called as the differential calculus. In a differential calculus, you study the differentiation, you study the applications of the derivatives, how to find the derivatives, or how to find the tangents, how to find the rate of change of quantity. So simply means differential calculus. In this differential calculus, we study simply the differentiation and its applications, which you already completed. Now the second branch is integral calculus. Now in a differentiation, the function is given, you need to find its derivatives. That is, if f is differentiable in interval I, then its f dash exists in I. You can find this f dash by using the process of differentiation. Now if we consider it is the converse, the statement of this very statement, if we consider the converse of this statement, that is, if f dash is given, now the question arises, can we determine a function such that f dash is the derivative of that very function? If such function exists, then that very function is simply called as the primitive, antiderivative, or simply the indefinite integral of a given function. So this means that in differentiation or in differential calculus, we have a function is given, we need to find its derivative, simply derivative. While as in integration, derivative is given, we need to find a function such that the derivative of that function is the given function. So if such function exists, then that very function is simply called as the primitive, antiderivative, or simply the indefinite integral of a given function. The process through which we find such functions is simply called as the integration. Such problems exists in real life, like if we if we have the velocity of an object. From velocity, can we determine its position? Yes, we can determine, because if we have the velocity, we can determine its the position. Now the position here is the indefinite integral of the velocity, or position here, or simply the distance, or position here is the antiderivative of the function, or the primitive of the velocity. So such problems exists in real world. This branch in which we find the antiderivatives is simply constitutes the integral calculus. This is called as the integral calculus, and it is a branch of the calculus. The two main objectives of this integral calculus is to find the primitive or antiderivative, which is simply called as the indefinite integral, to find the indefinite integral of the given function. Like if we have velocity, from velocity we need to find or we have to find the position of object, that is to find the indefinite integral. Second one is to find the area under the graph of the function under certain conditions, or when the graph is closed. So how we find the area? If we find finding area from the graph of the function constitutes the another portion of this integration, which is called as the definite integrals or definite integration. Now firstly, we will define the indefinite integrals. Since in differentiation function is given, we need to find its derivative, while is in integration, that is in indefinite integration, the derivative is given, we need to find a function such that the derivative given function is the derivative of that function which we find. In this way we can say that this differentiation and integration, or the inverses to each other, or inverses of each other to some extent. Later on I will show you with an example, is differentiation and integration generally an inverses to each other. That is why I write here to some extent. Now we know that the differentiation, like if we consider function differentiation of tan x is sec square x, that is derivative of tan x. This statement can be stated as derivative of tan x is sec square x. So which implies that antiderivative of sec square is tan x. Antiderivative of sec square is tan x. Now if we consider again the function like tan x plus c, where c is constant, arbitrarily constant, then the derivative of this very whole function, that some function tan plus c equals to sec square, because differentiation of tan is sec square, while as differentiation of c is 0. So this means that the derivative of tan x plus c is also sec square x, or simply the sec square x is the antiderivative of tan x plus c. Tan x plus c. So the antiderivatives or primitives or indefinite integrals by the definition by above example are not unique, although the derivatives of a function are unique. That is, there is only one derivative of a given function, while as if we consider its indefinite integral, it is not unique, because if we consider 0 is the derivative of 5, 0 is the derivative of any constant function. But this means the derivative of all such functions is 0, that is, which is unique for each function. But if we consider 0 as the antiderivative, then it is not unique. So simply we can say that if differentiation of this capital F function is fx, then we can simply write also d by dx of this capital F of x plus c is f of x. Here f of x by definition is called f of x plus c is called as the antiderivative primitive of a given function. It is not unique because there is the c. This c is the constant, which is called as the constant of integration, or simply the integrating constant. That is, this fx plus c, f of x plus c denotes the family of antiderivatives of f of x. So this means that the antiderivatives are not unique for a function. If f of x, here capital F of x is the antiderivative of f of x, small f of x, which implies that capital F of x plus c is the infinite family, or the family of functions which are the antiderivatives of f of x, which are the which are the indefinite integrals of small f of x. In symbols we can represent this family as this elongated s f of x into dx, that is integral of f of x dx. This integral is simply called as the indefinite integral of f of x with respect to x. Here this is the f of x plus c is the indefinite integral. So this means that if f of x is equal to integral of f of x dx equals to fx plus c, then f of x plus c is the indefinite integral of f of x. Here f of x, small f of x, is called as the integrand. X is the variable of integration. Like if we consider by this is the definition of indefinite integral. Like if we consider derivative of x raised to power n plus 1, which is n plus 1 x raised to power n, because by the x raised to power n rule of differentiation. Now we can write this as 1 upon n plus 1 d by dx of x raised to power n plus 1, which is x raised to power n. Now this 1 upon n plus 1 is constant, so we can take within this differential, so we can write this as d by dx of x raised to power n plus 1 upon n plus 1 equals to x raised to power n. So this means that the derivative of x raised to power n plus 1 by n plus 1 is x raised to power n. So by definition of indefinite integral of x raised to power n, this with respect to dx, with respect to x, is x raised to power n plus 1 upon n plus 1 plus c, provided this n equals not equals to minus 1, because if n equals to minus 1, then integration of x raised differentiation of x raised to power minus 1 is log x. So this means that this differentiation formula is not applicable when n is minus 1. Similarly, this indefinite integral of x raised to power n dx equals to x raised to power n plus 1 upon n plus 1 plus c is valid only when n not equals to minus 1. Like if we consider x raised to power 5 dx, then its indefinite integral by above is x raised to power 6 upon 6 plus c. Or if x raised to power 5 by 2 dx, then its indefinite integral is x raised to power 5 by 2 plus 1 upon 5 by 2 plus 1 plus c. So simply, after simplifying this, it is 2 upon 7 into x raised to power 7 by 2 plus c. So 2 by 7 x raised to power 7 by 2 plus c is the indefinite integral of x raised to power 5 by 2 with respect to x. So this is about, this is the definition of the indefinite integral and how to find indefinite integral by the definition. Inshallah, in tomorrow's video lecture we will discuss the few standard indefinite integrals of a given function. So thank you.